In this video, we'll talk about limits. Now, limits is one of those concepts that you see in pre-calculus that is very weird at first. And the core idea of it is you're trying to figure out, say I'm looking at a particular x value, what are my y values doing, is basically what it is. So if you think about it, it's almost like end behavior, but I'm looking at what happens in the middle. So the idea is I'm going to look at what happens as I come in from the left and what happens as I come in from the right and figure out kind of what happens in the middle. So let's dive right into an example. So some notation here. This would be a shorthand for saying, okay, I'm going to look at what happens as x approaches 5 for the following function. Now if we think about f of x equaling x squared, that one we have a pretty good grasp of, okay, it's a parabola, and at 5, my point is 25. So the idea is that as I move to the right, my values, my y values, are going to get closer and closer to 25. And likewise, if I'm coming from the left, also going to get closer and closer to 25. And that is what is required to make sure that a limit does exist, is that from both sides, it's approaching the same value. And in this case, since it's a continuous function at that value, we would say this limit, as x approaches 5, of x squared is equal to 25. They're both approaching that way because we look at it from the positive and negative side, it's both 25. This one makes sense because it's a continuous function. However, let's look at some ones that are not continuous because that's where things get different. So let's take a look at 1 over x, for example. Now I want to look at what happens at 0. Now we know 1 over x kind of looks like so. It has a weird break at 0, and if we think about it, from the right side, we're going to go off to positive infinity. And coming from the left, it goes to negative infinity. Now, these two things are not equal. The negative infinity does not equal the positive infinity. So a way of writing this is that if we're looking at the limit as x approaches 0 from the left, so that'd be our red curve, we put a little negative kind of up there, like almost as an exponent, of 1 over x would be negative infinity. And we usually, when we're talking about infinities, we draw an arrow. It approaches negative infinity. And likewise, the limit as x approaches 0 from the positive side goes to positive infinity. Since these two things are not the same, we would say our limit of the entire function as x approaches 0 of 1 over x, there's no one value that it tends towards, so it does not exist. And a shorthand in mathematics is just to write DNE. Does not exist. And that's because one side goes to positive infinity, one side goes to negative infinity. They are not going to the same place. It'd be like if we had a jump discontinuity. One side would be saying 7, the other side would be saying 4, for example. That would not exist either. Now let's take a look at another kind of strange example. So let's look at the limit as x approaches 0 of 1 over x squared. Now, very similar to 1 over x, there is an infinite discontinuity at 0. However, both ends are going off to positive infinity. Since they're both going to the same place, the limit does exist in this case. So we can say the limit as x approaches 0 of 1 over x squared, it approaches positive infinity. Because if you think about it, either way I come from it, it's going to positive infinity. So another way to read this is saying, when I'm getting closer and closer to 0 for this function, I will always, always get closer to infinity. Now that wasn't true for the 1 over x case, because depending on which side you're coming from, it may be going to positive infinity, it may be going to negative infinity. There is no one particular direction that it heads. And this is a complex topic in mathematics. It's difficult to grasp. It's very important for calculus, though, as a lot of those limits dictate what happens with derivatives and such.